Okay, ladies and gents, I am going through this section here on Organic Chemistry Worksheet on Alkanes. Alright, this paper is taken from 2012, paper 2B9. Or, okay, some fractions of crude oil are cracked to form smaller molecules. Right, there are two different types of cracking process. One is steam cracking, the other one is catalytic cracking. Okay, steam cracking, right, uses a temperature of 700 degrees C. This process breaks larger molecules into smaller molecules. You actually have dodecane, right, which formula C10H12. One of the molecule of dodecane is cracked, two possible products are formed. Okay, so if you were to ask to write the equation for cracking, right, you have dodecane, which is C10H22. Okay, to write the cracking equation, right, will be just the long chain hydrocarbon to form C6H14. Okay, and the other one, what you do is you take 10 minus 6, so 10 minus 6 will be C4. 22 minus 14 is H8. So C4H8 is actually butene. Okay, so the structure of hexane, you are asked to draw the structure of hexane. So here, so hexane is C6 and it is saturated, so it will have carbon to carbon single bonds. Okay, so this is the structure of hexane. The other compound, the name of the other compound, as what we have mentioned just now, is actually butene. Right, so butene, it belongs to the homologous series of alkene. Right, so it's carbon to carbon double bond for one of the bonding. Then the remaining of it, you add hydrogen. Do take note that every carbon can only form 4 hydrogen bonds, 4 covalent bonds. 1, 2, 3, so I can add one more. 1, 2, I can add 2 more. Okay, so this is the structure of butene. Describe a simple test to distinguish between hexane and the other compound. Ladies and gentlemen, alright, remember that C1 to C4, alright, these substances will be in the gaseous state. Okay, so in the gaseous state, if let's say it is hexane, hexane is C6, so you can add aqueous bromine. Right, the description is important. Alright, add aqueous bromine to liquid hexane. Alright, and then you bubble butane into aqueous bromine. Okay, so how does this bubbling look like? So meaning that if I were to draw like a delivery tube, okay, so this is my delivery tube. Okay, and here will be my aqueous bromine. Okay, so over here, this will be your butane. Okay, so this is the setup. So result with hexane, aqueous bromine will remain reddish brown. Okay, result with butane, aqueous bromine will turn from, oh sorry, it's not butane, it's butene. There's a spelling error here. Result with butene, aqueous bromine will turn from reddish brown to colorless. Ladies and gents, this is something that you cannot take for granted. It is aqueous bromine that changes color or remains reddish brown. Alright, so please do not say that the butane or the hexane right? You don't say that it's a hydrocarbon that changes the color, right? Because hydrocarbons are generally colorless. All right, for these substances that we are talking about. Okay, catalytic cracking occurs at a lower temperature of around 500 degrees C. Right, a powdered catalyst of alumina and silica is used. Alumina is aluminium oxide. Alright, silica is silicon dioxide. Okay, so where do I get this content from? Alright, if you were to look at your alkenes under the section of cracking here. Okay, so for cracking, the catalyst used is aluminium oxide and silicon dioxide. So just now, for that question just now, if it is said as alumina and silica, it means these two catalysts. Alright. Okay, the process produces branched chain alkanes. Petrol containing branched alkanes burn more smoothly, right, and leads to more complete combustion. Okay, so this is important, right? If you were to refer back to your notes under the effects of on isomerism or branching, okay, so if you were to refer back to your notes on alkenes, okay, under the effects of branching. Okay, here. Right, branch isomers have lower surface area compared to straight chains, so hence melting and boiling point decreases as the intermolecular forces decreases with branching. So this is the application of for application question to this concept. Okay, so draw a branch isomer of hexane. Okay, ladies and gents, like what we said just now, you always shorten by one carbon chain. Alright, so I will draw a 5 carbon chain first, then I will shift my one of the carbon CH3 here. Okay, and the rest of it, please remember to include your hydrogen. Okay, what are other possible compounds to be drawn? Okay, I can also move my carbon here. 1, 2, 3, 4, 5. Okay, I can put my carbon here, or I can also shorten by 4 carbon chain. Alright, and I have 1 carbon here, 1 carbon here. Alright, so since they ask you to draw 1, so it is more than enough. Okay, write the equation for the combustion of hexane. Okay, combustion of any hydrocarbon will give you carbon dioxide and water. Okay, so hence C6H14 plus O2 to give you CO2 plus H2O. Okay, I have 6 carbon atom, so I need a 6 here, 14 hydrogen, so that's a 7. So total number of oxygen will be 6 times 2, 12. 7 times 1, 7 times 1 is 7, so 19, 19 oxygen. Okay, so 19 divided by 2, alright, will give you 9.5. Okay, so for here, since it's 19, right, so you put a 19 divided by 2. Okay, ladies and gentlemen, if you are comfortable, if not comfortable with this, what you have been taught, okay, if I do not 19 divided by 2, so I get 19 oxygen, I can also put there as 9.5. However, okay, so however, if I want to make it a whole number, so what I can do is I can multiply the whole equation by 2. Alright, I multiply in this way. So my final equation will be 2C6H14. Alright, so you are doing the expansion of algebraic expression 1902, right, to give me 12CO2 plus 14H2O. Okay, so please take note. Alright, there are times that they actually leave the answer as 19/2. So you look at the examples that are given. Alright, so far what we taught the students is this. Alright, you multiply the whole equation by integer, which is 2. Okay, explain why incomplete combustion in car engines is undesirable. Okay, for here it is linked to the topic of atmosphere, which we have not covered yet. Alright, but for your information first, alright, incomplete combustion of any fuel produces carbon monoxide. And why is carbon monoxide dangerous? Because it prevents transport of blood in oxygen that can cause death. Alright, so that's why incomplete combustion of hydrocarbon is not desirable. Okay, why do you use catalysts which are powdered? If you refer back to the section on speed of reaction, so powdered catalyst has larger surface area, which increases the frequency of effective collision between particles, so hence the speed of combustion actually increases. C. There is a large demand for molecules in crude oil that can be used to make petrol. Both cracking processes are important to make sure that the supply meets demand. So explain how cracking helps the oil refinery meet the demand for petrol. Okay, so in your notes under cracking, alright, this is what I have mentioned. Alright, you have long fractions like lubricating oil, bitumen, which contain long chain of hydrocarbon. So these are lower in demand, so they are actually cracked so that they can meet the high demand of petrol, which can be used in vehicles. So this is the the explanation of cracking process, which is not needed. So over here what you need to mention will be the fractions which are cracked, and then after that the lower demands. So what are they used for? So for 2 marks that is enough. Alright, you do not need to mention about the cracking process itself. Okay, next, 2015 paper 2. This is a database question. You are given alkanes from ethane to octane, the formulas, the melting points, and the boiling points. Okay, so if you look generally, alright, right, so this will be the trend. Right, so as number of carbon atom increases, if you look here, my boiling point will increase. However, there is an anomaly here. It will decrease here, and after that, okay, there's a slight, not a very fixed trend here. Okay, so this one especially so is the anomaly. Okay, so they also specify the flash point is the minimum temperature at which, okay, the compound gives enough vapor to burn in air. Alright, it is important to consider when you are making blended fuels such as petrol, compounds with lower flash points, right, evaporate and burn more easily, okay, and can burn smoothly in car engines. Okay, so this is important. Okay, so this section here shows the effect of isomerism. Okay, so isomerism over here, table 2 is for straight chain alkanes. Okay, straight chain alkanes will have higher flash point. If you look here, the moment you actually have branch, the flash point actually decreases. So when the flash point decreases, so it means that it is easier to burn, right, this petrol. right, to produce energy. Okay, because of lower flash point. So generally for table 1 and table 2, melting and boiling point, what do you call it, of alkanes increases as the number of atoms increases. So table 2 talks about the flash point. So the flash point increases as the number of carbon atom increases. Okay, they say one of the alkanes appear to have a melting point that is different. So name the alkane, explain your choice. So if you look here, okay, so this is actually C2. Alright, this is actually C3. Okay, by right C3 should have higher boiling point. Okay, because it actually has one more carbon atom. Okay, so propane should have a higher melting point than ethane, as it has one more carbon atom than ethane. Okay, you actually have the formula of heptane. They ask you to predict the boiling point of heptane. Okay, the moment you are asked to predict, right, heptane is actually here. Here. So which means if there is a heptane, it will be C7H16. So long as your melting point and boiling point is in between minus 95 to minus 37 and between the boiling point of 69 to 128, your answer is acceptable. So what I gave the answer here to be is actually minus 80 and 100. Okay, the boiling point and flash point of straight chain follows similar trends. Okay, so describe these trends. So the boiling point and flash point of the alkanes increases as the number of carbon atom increases. Okay, so again you need to look here. Alright, this is the flash point for straight chain. Okay, and the other one is on the boiling point and flash point. So this is the flash point increases, and this is the boiling point that also generally increases. Okay, how is the flash point of a straight chain alkane affected by isomerism? So use the evidence from the information to explain. Okay, so for here, right, as stated in the passage, okay, that okay, compounds with lower flash point evaporate and burn more easily at lower temperatures, okay, and burn more smoothly. So from here, right, so compounds with lower flash points. So isomerism lowers the flash point of a hydrocarbon. So flash point decreases with increased branching. So you actually refer to table number 3, because for table number 3 it actually explains about what happens in the process if I have more branching. So if I have the same number of carbon atoms, okay, branch alkane 1, right, where I have a straight chain of 4 carbon atom here. This is a straight chain of 4 carbon atom. Alright, my flash point is minus 57. Over here, when I actually shorten by 1 carbon atom and I actually have more branching, my flash point is actually lower. So when it is lower, it is more easier to burn. Okay, so if the longer my straight chain is, okay, the higher my flash point. So which means if I have 8 carbon atoms, my flash point will be higher. So which means this is not easily burnt. Okay, so you quote, right, table 3, branch alkane with 5 carbon atoms, minus 57, and pentane has flash point of minus 23. So you compare between the branch alkane and after that the straight chain alkane with the same number of carbon atoms. Alright, so this is a 4-mark question. Alright, so it is important that you actually use data to code. Right, branch alkane 2, right, which also has 5 carbon atoms, has more branching than branch alkane 1. Right, so because of this, it has lower flash point minus 65 compared to alkane 1, which is minus 57. Right, the most important is this, okay, that isomerism lowers the flash point of a hydrocarbon. Okay, F. Petrol contains straight chain octane. Other compounds can be added to improve the performance. In cold country, use blended petrol. Okay, so blended petrol contains pentane and branch alkane 2. Okay, branch alkane 2 is actually here, the one that has shorter carbon chain, so it burns easier compared to a straight chain. Okay, so why is this mixture works better than pure octane alone? Okay, straight chain octane requires higher temperature for ignition. Okay, so it's difficult to achieve during winter. Okay, because winter the temperature is low. Okay, it's very difficult to reach higher temperature. So higher temperature means you need more energy to burn. Okay, addition of pentane and branch alkane 2 lower the flash point, so hence making it easier for it to burn. Okay, here lower the flash point, making the petrol easier to be ignited. Okay, next question. Okay, petrol tanks are not airtight. Winter blend petrol is not sold in hot weather conditions because it leads to increased loss of petrol. This increased loss of petrol is actually via evaporation. Okay, so which means when you have a decrease in flash point, boiling point will also decrease. Okay, so this leads to the petrol being able to evaporate, leading to increased loss in petrol. Okay, so at high temperature, right, if there is a decrease in flash point, boiling point will decrease. Okay, when they say boiling point is the change of from liquid, alright, to gas. Okay, so with that increase in temperature, alright, it will vaporize easily. Alright, so in Singapore we don't have this worry because our what do you call it, our petrol tanks are normally, it's not very airtight, but it's quite okay. Alright, so this actually happens very much in what do you call it, in countries with 4 seasons. Alright, so after this, alright, you can review alkenes and then followed by the student practice question, then you can actually work on the alkenes worksheet.